Welcome to a new video, our great students. In this video, we shall discuss curved mirror. In the first video under reflection, we did plane mirror, and today we shall be looking at what curved mirror and parabolic mirror. And before I go into that, I just want you to know this, that reflection reflection occurs on mirror, either curved mirror or plane mirror or parabolic mirror. Reflection occurs on what? Mirror. While refraction occurs on lens. Refraction occurs on lens. Reflection on mirror, either plane mirror, parabolic mirror, spherical mirror, which is curved mirror. Reflection occurs on mirror. Refraction occurs on lens. Why both of them? Both reflection and refraction occur on thick glass, like what? Triangular glass prism, rectangular glass prism. Both reflection and refraction occur on thick glass. Reflection occurs on mirror, refraction occurs on lens. Both reflection and refraction occur on thick glass. Then let us go to our work for today. Today we shall discuss what? Curved mirror and parabolic mirror. That means curved mirror and parabolic mirror. These are the two things we shall look at. Before I go into curved mirror, we shall talk about parabolic mirror. Parabolic mirror is a special type of mirror that is very expensive to make. That is why we don't use parabolic mirror. That's why we go for curved mirror, because parabolic mirror is very expensive to make. When you have parabolic mirror, I say it's a type of mirror that is very expensive. When you have something like this, a parabola shape, you see, it's different from what curved mirror that is spherical. Curved mirror is what? Spherical. Well, parabolic mirror has what? A parabola what? Shape. It has a parabola shape. This is the polished side. At this side, the parabolic mirror is flat, but at this side, this is what? A kind of what? A parabola shape, very curved. Then when you have this, you have the pole, you have the focus, that means principal focus, and you have center of what? Curvature. A parabolic mirror is a very special type of mirror in which all the rays of light parallel to the principal axis. This is principal axis. It's an imaginary line from the pole to the center of curvature, in which all the what? Rays of light parallel to the principal axis. All of them converge. They converge at a point. All rays of light under parabolic mirror converge at a point. All rays of light under parabolic mirror converge at the point. That means it has a single principal focus. Parabolic mirror, take note. All rays of light, that means beam. Don't forget, what is ray? A ray of light is the path in which light travels. A ray of light, take note of that. A ray of light is the path which light travels. Is the path in which light travels. PATH. A ray of light is the path in which light travels. The collection of rays of light is known as what? Beam of light. When you have rays of light or rays of light parallel to the principal axis, this is the principal axis from the pole of the mirror to the center of curvature is an imaginary line. All these rays of light parallel to the principal axis, they converge at a point which is known as what? The principal focus. All rays of light parallel to the principal axis on a concave mirror converge at a point. That means all rays of light parallel to principal axis converge at a point known as what? Principal focus. Known as principal focus. That means parabolic mirror has a single focus. That is parabolic mirror has a single, take note, very important, single word focus. That means single word principal focus. It has a single focus. Parabolic mirror has a single focus. It's a kind of mirror that can give what? A perfect focus. Take note, it can produce. It's a kind of mirror. It is a kind of mirror that can give a perfect focus. That is a single focus. And because the parabolic mirror is very expensive to make, that is why we now go for what? Curved mirror. That is why we go for what? Curved mirror. And what are the uses of parabolic mirror? Uses of parabolic mirror. Number one, it is used in production of a satellite dish. It is used in what? Satellite dish. Take note of that. It is used in searchlight. It is used as headlamp of a car because it can produce parallel beam of light. It can produce parallel beam of light. These are some out of the world, few out of the world uses of what? Few out of some of the uses of what? Parabolic mirror. These are few out of the world uses of parabolic mirror. It can be used in production of a satellite dish because of the shape. And it can be used in what? Searchlight. It can be used as one headlamp of a car because it produces what? Parallel beam of light. It can produce parallel beam of light. Don't forget, I told you that because it's very expensive, that is why we go for what? Curved mirror. And that is what we are going to talk on. Curved mirror. Let us write curved mirror. Curved mirror. Yes. Let's look at curved mirror. Curved mirror, which is also known as what? Spherical mirror. The shape is spherical. Spherical mirror. It's also known as what? Spherical mirror. And we have two types of what? Curved mirror. We have concave mirror, which is also known as what? Converging mirror. And we have convex mirror. Which is also known as diverging mirror. These are the two types of spherical mirror. They are different from what? Parabolic mirror. I told you parabolic mirror give a single focus. But this concave mirror and this convex mirror do not give a single focus. Take note, because of their shape. Their shape is what spherical, but parabolic mirror has a parabola shape. It has a parabola shape. That is why it can give the word a single word focus, a perfect focus. But these two, because they are spherical, they are not parabola in shape, they are spherical in shape, they don't give a single focus because they are cheap to make. These are cheap to make. But parabolic mirror is very expensive to make. That's why we go for curved mirror. We shall be looking at curved mirror. We shall look at curved mirror based on the scheme of work. I said we have two types of curved mirror: concave mirror and convex mirror. Let us look at the shape of concave mirror and the shape of a convex mirror. And we shall look at all the parts of our concave and convex mirror. This is when you have something like this. When you have this, when you have this, where you have the polished surface outside. This is the polished surface. And you have the reflecting surface inward. The reflecting surface is what bent inward. When you have something like this, this is what concave mirror. Concave mirror. Then the part we have in concave mirror, we have the pole, we have principal focus, and we have center of curvature. And for convex mirror, where you have something like this, where you have something like this, where you have the reflecting surface outward, and you have the polished surface. This is the polished surface inward. You have the polished surface inward. Then you have something like this. This is the pole, the F, and the C. We have F and C. That is that. This is convex mirror. Convex mirror, which is also known as diverging mirror. I told you this is also known as converging mirror. This is known as diverging mirror. Then let us look at the parts. All the parts we are, all the parts on our concave mirror. What is principal focus? This capital F is principal focus. Is the principal focus. What is principal focus on a concave mirror? The principal focus on a concave mirror. The principal focus on a concave mirror. On a concave mirror. The principal focus on a concave mirror, that means capital F, is the point at which rays of light parallel to the principal axis. This is the principal axis, this line. Let me give you principal axis. Principal axis. What is principal axis? It's an imaginary line drawn from the pole of a mirror to center of curvature. Principal axis. Let me write it down. Principal axis. This is an imaginary line drawn from the pole of a mirror, of a curved mirror, of a curved mirror to center of curvature. To center of curvature. Take note of that. I said principal axis is an imaginary line. It's an imaginary line drawn from the pole of a curved mirror to center of curvature. It's an imaginary line drawn from the pole of a mirror, to center of curvature. That is what principal axis. This line is a principal axis. Then on the principal axis we have F, which is principal focus, which we want to look at the principal focus of a concave mirror. the principal focus of a concave mirror. This is center of curvature. Thank God I've given you all principal axis. I said it's an imaginary line. Then what is principal focus? Principal focus is a point where rays of light, these are rays of light parallel to the principal axis, where they converge after reflection. That is what the principal focus of a what? Concave mirror. The principal focus of a what? Concave mirror. Where you have rays of light, that means parallel beam of light. Rays of light parallel to the principal axis. Rays of light or beam of light parallel to the principal axis. Where they converge, where they meet after reflection. That is principal focus of a concave mirror. Then let us look at the principal focus of a convex mirror. The principal focus of a convex mirror. This one, the principal focus of a convex mirror. Let me write this one for concave mirror. The principal focus of a concave mirror. This is a point where rays, that is beam of light, rays, is it okay like this? Where rays of light, beam of light, rays of light converge after reflection. That means this is a point where rays of light converge after reflection. That is that. Then let us look at the principal focus for convex mirror. I believe you've written this. The meaning of principal axis is an imaginary line drawn from the pole of the mirror to center of curvature. The pole of the mirror to center of curvature. That is principal axis. It's an imaginary line. Okay, let me rub it off. Then let us look at the principal focus for convex mirror. Principal focus. Principal focus for convex mirror. Convex mirror. Convex mirror. Principal focus for convex mirror. Take note. Principal focus for convex mirror. Principal focus for convex mirror. In the case of principal focus for convex mirror, where you have is a point where rays of light, the rays of light or beam of light, parallel to the principal axis. Parallel to the principal axis, where the point where rays of light parallel to the principal axis diverge after reflection. That's why it's called diverging mirror. Diverge after reflection. That means it's a point where rays of light parallel to the principal, these are the rays of light parallel to the principal axis, where the point where they diverge, they move out. The point where they move out, they diverge, they move out after, or they spread out. The point where they spread out after reflection. This one is where the point where they converge, they meet after reflection. For convex mirror, the point where they diverge after reflection. This is principal focus of the word convex mirror. Let me write it down. This is a point. Where rays or beam of light diverge after reflection. Don't forget I told you reflection occurs in mirror, either plane, curved, or parabolic mirror. That is that. Please take note of that. That means you've known the meaning of what? Focus for what? Concave mirror, and you've known the meaning of what? Focus for what? Convex mirror. Now let us look at the meaning of what? Center of curvature, the meaning of what? Pole, and the meaning of what? Radius of curvature, and the meaning of what? Focal length. Let's look at that, please. I hope that pause the video and quickly look at this, draw it down. We have two types of curved mirror. They are what? Convex mirror, and concave mirror. That is converging, which is concave mirror, and what? Diverging, which is also known as convex mirror. Concave mirror, which is known as converging. Convex mirror, which is known as what? Diverging. And I believe that you understand the meaning of their word, principal focus. If not, you can rewind the video and look at it to understand better. Then let us look at the other parts of a mirror. The other part of this curved mirror. The other part of the curved mirror. The other part of the curved mirror. The other part of the curved mirror. Okay. If you have this, we have the pole, we have F, we have C, and I've given you the meaning of what? This line, principal axis. Then what is between the pole and the principal focus? The distance between the pole and the principal focus is known as what? Focal length. Take note of that. Take note of that. That means there's a question that came out on this last year in UTME. We shall look at the question after everything because we are going to solve a lot of questions. The distance between the pole and what? Principal focus is what? Focal length. Focal length. Please don't mind my pronunciation. Focal length. Focal length. Just don't mind my pronunciation. Focal length. This distance between the principal focus and the pole. Then the distance between the pole and the center of curvature. This distance between the pole and the center of curvature. The distance between the pole and the center of curvature is known as what? Radius of curvature. That means R is known as radius. Radius of curvature. Radius of curvature. Radius of curvature is the distance between the pole and the center of curvature. While the focal length is the distance between the pole and focus, principal focus. And don't forget, radius of curvature is twice principal focus, focal length. I'm sorry. Radius of curvature is twice what? Focal length. Radius of curvature, this distance, that means from principal focus, capital F, to C. Capital F is principal focus. And I've given you that. While small f is what? Focal length. Focal length is the distance between the pole and F, principal focus. The radius of curvature is the distance between the pole and center of curvature. And the radius of curvature is twice. That means two times what? Focal length. That means from the pole to F, focal length, I can say from the principal focus to center of curvature is another one, focal length. Then focal length plus focal length, that means F plus F, will give you 2F. That means radius of curvature is what? Twice what? Focal length. Take note of that. Then what is center of curvature? What is center of curvature? Right? Center of curvature. Center of curvature. Right? This is the center of the sphere in which the mirror forms a path. Is the center of the sphere in which the mirror forms a path. The center of the sphere, that means the center of the spherical mirror in which the mirror forms a path. That is what center of curvature. This is the center of the sphere in which the mirror forms a path. That is that. Please take note of this, because I will still use this under what? Mirror formula. I will still use this under what? Mirror formula. We still use this under mirror formula. This formula. Radius of curvature is twice what? Focal length. And what is focal length? Is the distance between the pole and what? Principal focus. While radius of curvature is the distance between the pole and what? Center of curvature. And radius of curvature is twice what? Focal length. Center of curvature, this is the center of the sphere in which that means of the spherical mirror in which the mirror forms a path. Take note of that. Let us move toward the ray diagram. Ray diagram. Ray diagram. See, old pirate, yes, they robbed. So I told him my nation, meaning after they took I. Okay, look at this. Ray diagram. Ray diagrams for concave mirror. Let us look at ray diagram for concave mirror. Once you understand the one of concave mirror, the same is applicable to what? Convex mirror. Let us look at the ray diagrams for concave mirror. The ray diagrams for concave mirror. Please, I want you to follow me on this topic because it's very important. And we are going to solve question from JUPEC last year, 2023. A-level question JUPEC, Joint University Preliminary Examination Board exam. We are going to solve question. They solve question from JAM and from WAEC before we call it a day on the video. Ray diagram, the first one. The first one, ray diagram. A ray of light parallel to the principal axis. Passes through the principal focus. The focus passes through this principal focus. The focus of principal focus after reflection. Don't forget, reflection occurs on mirror, either plane or curved mirror. A ray of light. Let me put of light. I told you this question, what is a ray? A ray, this is the path which light travels. The path which light travels is a ray, or the direction in which light travels. The path or the direction in which light travels is known as ray. The collection of ray is known as what? Beam. Don't forget that. Then we have it. A ray of light parallel to the principal axis passes through the word principal focus after what? Reflection. What do we mean? This is what we mean when you have a concave mirror. This is the pole of the mirror, which is the center. Then you have F, focus, center of curvature. When you have a ray of light parallel to the word principal axis, this is the principal axis. It's an imaginary line. The area of light parallel to this principal axis passes through principal focus after reflection. That's what I mean. A ray of light parallel to the principal axis. This is the principal axis. This ray of light is parallel to this principal axis. A ray of light parallel to the principal axis. This is principal axis. This ray of light is parallel to this principal axis. Then it passes through the word focus after what? Reflection. Look at my arrow. After reflection, it passes through the word focus. That is the first principle. the force ray diagram principle. Please write it down, look at it, you can pause the video, then look at it once more. Let us go to the second one, number two. Number two. Number two. Number two. Number two. Number second. Number second. Number second. A ray of light. A ray of light. A ray of light that passes through center of curvature. Center of curvature. Center of curvature is reflected through same path. Through same path. Is reflected through same path. Take note of that. A ray of light that passes through the wall center of curvature is reflected through same path. A ray of light that passes through the center of curvature is reflected through same path. A ray of light that passes through the center of curvature after reflection, it passes through the same path. A ray of light, this is it. When you have concave mirror, pole, which is P, F, and what? C. This what I mean? A ray of light that passes through what? Center of curvature. This center of curvature. It passes through the center of what? Curvature. It's reflected through same path. Through same path. A ray of light that passes through center of curvature reflected through same path. Take note, the angle in which this one is reflected is what? 0 degree. Take note, it's there in your past question. The angle in which a ray of light that passes through the center of curvature after reflection, the angle it is reflected is known as what? 0 degree. That angle is 0 degree. When a ray of light passes through the center of curvature, it is reflected through same path. Then the angle that is being reflected is what? 0 degree. Take note of that. Let us move to the third ray diagram. The third one, the third ray diagram. I believe you can pause the video, watch it, and draw it yourself. How do you learn? After reading, pause the video, practice what you have read. Read for 10 minutes, pause the video, practice it for 2 minutes. That means when you read, when you get a point, pause the video, practice it yourself. Practice what you've learned. Pause the video, practice. That is how you learn. Thank you. Let's move to the third one. The third one. The third one. Number three. It's just the opposite of the first one. Opposite of the first one. A ray of light that passes through focus. That means principal focus. That passes through focus. If I say focus, you should know I'm talking about principal focus. A ray of light that passes through a focus is reflected parallel to the principal axis, to the imaginary line, the principal axis. Is reflected parallel to the principal axis. A ray of light that passes through the wall focus is reflected parallel to the principal axis. Let us look at the first one. The first one I gave to you, the first ray diagram. Let me just draw it here. I told you the third one is the opposite. I said a ray of light that is parallel to the principal axis passes through F afterward reflection. Then this third one is now saying opposite of this. Opposite. You have pole, F, and what? C. A ray of light that now passes through what? F Can you see? A ray of light that passes through F is reflected parallel toward principal axis. Can you see? It's an opposite of the first one. This is the first one. This one, third one. A ray of light that passes through F is reflected more parallel to the principal axis. Please take note of that. You can pause the video and look at it. But we are going to use this. We are going to use this to draw the position of image that will be what formed when an object is placed on different parts of a concave mirror. We are going to use 2 out of these 3 ray diagram. We are going to use 2 out of this 3 ray diagram to do that. Please pause it. One love, one heart, let's get together and feel alright. Hear the children crying, hear the children crying. Give thanks and praise to the Jah, and now we. Okay, let's look. Right, position of image formed when an object is placed on different parts on a concave mirror. Let us look at the position of the image that will be formed, the nature of the image, and characteristics of the image that will be formed when an object is placed on different parts on a concave mirror. The first part, number 1, when an object is placed beyond center of curvature, C, center of curvature, C, center of curvature, C. When an object is placed beyond C, where will the position of the image on the concave mirror? This is the concave mirror. This is the concave mirror. I'm sorry with my diagram, because some people can draw better. I cannot draw. I'm just managing. When you have this, pole, F, and what? C. The first position of the object, when an object is placed beyond center of curvature, beyond any part beyond center of curvature. Take note of this. When an object is placed beyond C, the image is formed between C and F. And take note of this in a simple way. When you move the object closer to the concave mirror, the image moves backward. When you move the object closer to the concave mirror, the image moves what? Backward. Let that be in your mind. When you move the object closer, look at this. The first position of the object is beyond C. Let us look at this. Please, I want to explain something. The first position of the object is beyond C. The second position of the object will be on C. The third position of the object will be between C and F. The next position of the object will be on what? F. The next position of the object will be between F and the pole and the mirror. The pole means the mirror. And the next position of the object will be at infinity. Let me re-explain. The first position I'm taking is beyond C. The first position of the object is beyond C. After this, the next position of the object will be what? On C. The next position of the object will be between C and F, between center of curvature and principal focus. The next position of the object will be on F. The next position of the object will be between F and what? The mirror, the pole. Will be between F and the what? The pole or the mirror. Listen, first position beyond C. And as you are moving the object closer to the mirror, the image moves what? Backward. As you are moving the object closer to the mirror, the image moves what? Backward. Take note of that. That means on this, when you have the object placed beyond C, what will happen? The image is formed between C and F. That means out of the three ray diagrams, I'm using two. The first one, a ray of light parallel to the principal axis passes toward F after reflection. Take note of that. Then a ray of light that passes through center of curvature. Center of curvature. This center of curvature. That passes through center of curvature. That passes through center of curvature is reflected through same path. Through same path. Then where these two ray diagrams, where they meet, the point they meet, that is where the image will be formed. They meet at this point. That is where the image will be what? Be formed. This is the head of the image. This is the tail. Then look at this. The head of the image is what? Upside down. While the tail is what? Up. This is the image. This is the image here. This is the image. This is what? Object. Look at it. The image is formed between C and F. Then what are the characteristics of this image? Characteristic of image formed when an object is placed beyond C. Number one, the image, can you see the image is smaller compared to the what? Object. The image is smaller compared to the object. And when image is smaller compared to object, that means it is what? Diminished. Diminished. The image is what? Diminished. Diminished. The image is what? Diminished. Number two, can you see the image is what? Upside down. That means what? Inverted. Inverted. Upside down. The image is what? Inverted. Number three, can you see the image is formed in front of the mirror. When image is formed in front of a mirror, image is what? Real. Real. Not like plain mirror. The image of a plain mirror is formed behind the mirror. And when image is behind the mirror, is what? Virtual, not real. Image is real when it is formed in front of the mirror and when it is formed on a screen. When image is on a screen or formed in front of a mirror, that image is real. But when image is behind the mirror, that image is what? Virtual, not real. And look at this one. This one is formed in front of the mirror because the object is in the front of the mirror. This is reflecting surface. This is polished surface. This is reflecting surface. Then the image is in front of the mirror while the object is also in front of the mirror. The image is formed in front of the mirror. The image is what? Real. Number four, what is the position of the image? The position of the image is between center of curvature and what? Principal focus. The image is formed between C and F. Take note of that. Please, you can pause the video and watch that over and over and over again. Let us move to the second one. I told you the next position of the object. If you move the object, the next position is on what? C, center of curvature. And when the object comes on C, what happens to the image? The image moves backward. When you move the object closer to the image, mirror, when you move the object closer to the mirror, the image moves backward. Just know this first one. If you know this first one, you know the other. The first position of the object is beyond C. That's what I'm taking. The first position, beyond C. Then the image is formed between C and F. These are the characteristics of the image. Inverted, very small, diminished, real, and between position C and F, center of curvature and principal focus. Move the object. The next position is to move it on C. What happens to the image? It will move backward. And when it's moving backward, the position for it will be on what? C. Then if I place the object here, what happens to the image? It will also move backward. That's it. The more you bring the object closer to the mirror, the image will move backward. The next position of the object is on C. I will put the object on C. The image will move backward on C. If I move the object between C and F, the image will go backward beyond C. Take note of that. Then let's go to the next one. Let's go to When an object is placed on C, when an object is placed on C, that's the next one. When an object is placed on C. On C means center of curvature. When you have an object on C, you have this one out, one out. When you have this, when an object is placed on C, this is the pole, this is F, this is what? C. When an object is placed on C. I told you the image will be on what? C also. The first ray diagram, I will use the word, the first and what? Third one. Because the object is on C. The ray of light cannot pass through C. Why? Because the object is on C. The first one, a ray of light parallel to the principal axis passes through what? F after reflection. Take note of that. The next one, a ray of light that passes through F, which is the third one, passes through F, is reflected parallel to the principal axis. A ray of light that passes through F is reflected parallel to the principal axis. A ray of light that passes through F is reflected parallel to the what? Principal axis. And where do they meet? They meet at this point. That is where the they meet on this point. That is where the image will be formed. This is the object. This is what? The image. The image. That is where the image will be formed. Can you see? Another, when I bring this one here, this one will go backward. Can you see? Let us look at this. What are the characteristics of this image? Number one, can you see? You see what? Inverted. It is inverted. Inverted. It's upside down. Number two, look at it very well. It has the same size as the object. It has the same size as the object. That is, magnification is 1. When an object and the image formed have the same size, magnification equal to what? 1. Why? Because magnification is the ratio of image distance or image height or image size to object size. And when they have the same size, that means magnification is 1. They have the same size, magnification is 1. Like plane mirror, the image and the object have the same size. That means magnification of plane mirror is 1. This one too, the magnification is 1. That means the image has same size. Same size as the object. That means magnification is unity. That means 1. Magnification is 1. And take note, they will ask you, when can magnification of plane mirror be equal to the magnification of a concave mirror? When an object is placed on center of curvature. When an object is placed on center of curvature on a concave mirror, the magnification of that concave mirror will be the same thing as what? Plane mirror. That means the image form will have the same size as what? Object. Take note. That means plane mirror and curved mirror, they have the same magnification of 1. When an object is placed on center of curvature on a concave mirror, take note of that. Magnification is 1. Number 3, the image is what? Real. Then number 4, the position of the image is on center of curvature. C. Position of the image is on center of curvature. Let's move further. Because of time, we need to be fast. Let's move to third one. When you now bring the object to the front, what happens? The image go backward. That means I have this. Yes. When the object is now between C and F. That means let us be fast. C and F. When the object is between C and F, this O, this F, this C is between C and F. Object. What happened? The image 2. That means a ray of light parallel to this passes through this. You have this. Then what do you have again? You have a ray of light that passes through what? Center of curvature. This center of curvature. Center of curvature. I'm sorry for my diagram. That passes through what? Center of curvature. That passes through center of curvature is reflected through same path. Then if you draw the diagram, they meet at this point. This is where they meet. This is where the image is formed. They meet at this point. This is where the image is formed. This is where the image. This is the image. This is the image. This is the object. I see. As you are moving the word object to the front, the image is coming back. What are the characteristics? Because of time. Characteristic number 1. The image is what? Ray is formed in front of the mirror. Number 2, I say the image is bigger than the object. The image is bigger than the object. That means it is what? Magnified. Magnified. That means enlarged. Enlarged. Number 3, the image is what? What again? Inverted. Upside down. Inverted. And the image, number 4, is what? Formed beyond C. The image is formed beyond C. And see, when an object is beyond C, the image is formed between C and F. Then when an object is between C and F, the image is formed beyond C. Opposite. When an object is beyond C, the image is formed between C and F. Very small image. But when an object is placed between C and F, the image is formed beyond C. Very large image. I see. Let's move. The next position will be what? On F. On F. Next position placed on F when the object is placed on F. In this one gives what? When the object is placed on F, it gives what? Image at what? Infinity. Image at what? Infinity. Image at what? Infinity. Image at infinity. Image at infinity. When an object is placed, you have this, because of time, you have F, you have C. What do you have? Passes through. Then a ray of light that passes through the center of curvature, is reflected through same path. If you keep drawing, they will never meet. They will meet at infinity. If you keep drawing, they will meet at infinity. In this case, the characteristic of the image form here is the image is at infinity. The image, it is at infinity. Infinity. The image is at what? Infinity. That means the image is at what? Infinity. It is at infinity. Characteristic of image form is at what? Infinity. That is that. Let us look at the last one before we call it a day. The last one, the next position will be between the mirror and F. Between the mirror and F. That is the next position. The object will be between the mirror and F. The object will be between the mirror and F. Let's look at that. When the object is placed between the mirror and F, that is between focus and mirror. That is mirror means or pole between when an object. What do we have? We have something like this. We have something like this. We have this something. We have P and C. When you have the object here, what happens? Passes through here. That's first one. Then the second one, that means like this. Then You have, I'm sorry, please mind my, I mean, this is center of curvature. Center of curvature. What happened? You have something like this. Is there. That means when a ray of light passes through the word center of curvature, it is reflected through the same path. If you extend your word diagram here, nothing they won't meet, but let us extend our diagram at this point. We have this, we have this, we have this. That means we have this. The diagram, the image is formed here. And look at the image. This is the image. The image is formed here. This is what? Object. The object. The object. What are the characteristics of this image? Characteristic. Number one, the characteristic of this image. Number one, it is what? Upright. Are you see? The image is standing upright. It is what? Erect. Number two, the image is what? Bigger than the what? Object. Are you see? It is what? Magnified. Magnified. Number three, can you see? The image is formed behind the mirror. The image is formed behind the mirror. When image is formed behind the mirror, it is what? Virtual. It's not real. Number four, the position of the image is what? Behind the mirror. Behind the mirror. Take note of that. Behind the mirror. The last one for today, when an object is placed at infinity. When an object is placed at infinity, where will the image be formed? The image will be formed at F. When an object is placed at infinity. 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 This is it. You have object at infinity. This is the pole. This is F. This is C. The object is at infinity. Object at infinity. The object is at infinity. Object at infinity. That is a ray of light parallel to the principal axis. Passive a ray of light parallel. That means the image is formed on what? F. This is where the image will be formed on F. This image is formed on F. When an object is what? Placed at what? Object. Object at infinity. Object at infinity. What are the characteristics of the image? Number one, it is what? Point size. Point sized. That is very, very diminished. Very, very diminished. Point size. Come. It is placed on what? It is formed on principal focus. Number two, the image is what? Real. As you see, it's real, but it is point size. Number three, the position is on F. The position of the image is on F. The position of the image is on F. Take note of that. When you have object at infinity, the position of the image is on F. It will be formed on F. Point size image, which is real, and position is on F. Take note of that. But let us, before we call it a day on this video, for convex mirror, just in any position you place an object on the convex mirror. In any position you place an object on a convex mirror. The characteristics of image formed by convex mirror when an object is placed at any position is this depth. I will use depth. D means what? Diminish. E means what? Erect. D means virtual. That means it's either you remember this def or verb. They mean the same thing. Virtual, erect, diminished. That means when you have something like this, that means you have this F, this C. This is an object, any position. Then you have a ray of light parallel to the principal axis passes through what? F. Afterward, reflection. After reflection. Then you have a ray of light from center of curvature. From center of curvature. Let me use broken lines. From center of curvature. From center of curvature. From center of curvature is reflected through the same path. Is reflected through the same path. Where these two lines, where they cross, that is where the image will be formed. This is the image. This is the image. Can you see that the image is what? Is erect. Can you see? Is erect. Then the image is diminished, smaller than the what? Object. And the image is what? Virtual, because it is formed behind the mirror. The image is formed behind the mirror. Take note. Let me give you the uses. Uses of convex mirror. Convex mirror. It is used as a rear mirror of a car. The side mirror, the rear mirror, to watch behind you. Rear mirror. It is used as what? As security mirror. Yeah. And it is used as reflector of street light. Street light. Take note. It is used as reflector of what? Street light. And it is used as what? Security light also. Security mirror. It can also be used, the same thing as mirror. It can be used as security what? Mirror. Take note. These are what? Security mirror. Security mirror. These are the uses of convex mirror. Look at the uses of concave mirror. The uses of concave mirror. This one do come out in your jam. This one as rear mirror, the side mirror to watch behind you when you are driving. Don't worry. The concave mirror. Concave, it can be used as what? In dental surgeon mirror. That is as a dentist mirror. It can be used as dentist mirror. It can be used as shaving mirror. Shaving mirror. It can be used as what? Shaving mirror. It can be used as makeup mirror. It can be used as what? Makeup mirror. It can also be used as what? As searchlight mirror. Searchlight mirror. Searchlight, rather. It can be used as searchlight. Mirror is what? Searchlight. Take note. And don't forget, parabolic mirror is better used as searchlight than concave mirror. But because of parabolic mirror is very expensive, that is why we take this one into use. It can be used as searchlight mirror. Take note. This one to come out in your jam as what dentist mirror. Please, in the next video, we shall go for the word calculation. Or calculation on this using what? Mirror formula. Take note. Make sure that you subscribe to this video to get more video and what? Comment and share with your friends. May God bless you.